We can start the second part of the session number 3. With the next speaker is Ilgmārs Eglītis, sorry if my pronunciation is wrong, from the Institute of Astronomy of the University of Latvia. He's reporting about observation of near-Earth objects and main belt asteroids in 2018, 2021, using the Baldone Schmidt telescope.
Okay.
Yes, yes, perfect. Thank you.
We are from Institute of Astronomy of University of Latvia, and we research the asteroids, neo and main belt asteroids. We operate with the Baldone Schmidt telescope. It is a Zeiss which has the mirror 1.2 meter in diameter, and in the focus are installed 2 CCD cameras, which every cover 1 degree of the sky. During 2018-2021, in 221 observation lines, we obtained more than 5,000 CCD images with the exposition 480 seconds, which covered about 650 degrees of the sky. More than 6,000 astronomical positions for 1,122 asteroids were published at MPC, and 49 asteroids discovered at first. For one asteroid, number 545,619, which also is discovered in Baldone Observatory, is named by Lapuska. It is a Latvian astronomers who promoted the development of the satellite laser ranging at University of Latvia. Reduction of CCD images was done with the programs Astrometrica, SkySift, and Colitech. SkySift program better work in equatorial fields where many stars, and Colitech give better results when Sirius at night for one asteroid contains more than 4 or more CCD images. For monitoring, we work in ecliptic region, but when we try to siege the neo asteroids, then we work at higher latitude, higher than 50 degrees. Observations, more than 3,000 CCD images devoted to studying the photometric characteristics of 25 neo-type asteroids, which is brighter than 17 or 18 in V magnitude, V passband. The list of objects was obtained using NEO checker of Minor Planet Center, and corrected by data from MPC light curve database. We observed only NEO, which know the rotation periods. Observations, of course, made with Baldone Schmidt telescope at R Gaia passband. On average, 160 CCD images were obtained for every NEO, mostly with exposure 240 seconds to obtain the good signal to noise. Usually, we obtain 6 to 8 observational series for each asteroids. Brightness measurement were done with the Maxim-Dell program. The average magnitude of asteroids in series at the night was calculated and removed from the individual measurements of brightness to take into account the varying brightness on the different nights as it moves away on or approaches Earth. The individual differences of brightness were analyzed using the two-period Fourier series method given by Pravec at 2000. The form of fitted two-period series is given here. The program is created in Python script. The calculation range for period is from 0 to 80 hours with a step of 15 minutes. We obtain 48 period for neo-asteroids. Here in table we can see the period, error of period, and amplitude of magnitude in R Gaia passband. No, it is not so. Okay, these two tables contain whole 48 data, asteroids data. We obtain some sinusoidal light curves of asteroids as for greater periods we obtain this similar longer periods light curves, and also some exotic light curves, which is interesting for modeling of the shape of the asteroids. Here is distribution of periods and amplitudes for research asteroids, but it is only for informational purposes because we have selective list of asteroids and not whole asteroids detection. One asteroids give Fourier periodogram which fits two periods of asteroids close, one 1.9 hours and second 5.6 hours. The 1.9 multiplied by 3 give 5.7. With close intensity or variability. It is to understand this asteroid period light curves, which is real, we need more detailed investigations. Both these light curves is from the Fourier analysis. Results of this research, the periods for 48 asteroids are obtained. Period range for these asteroids are from 0.8 till 25 hours. The brightness amplitude in Gaia passband is from 0.14 till 1.2. For asteroids 1999, Fourier analysis give very complicated periods. Better results are obtained when series in one night has long range, and the determination of the surface features requires additional research. Thank you for attention.
Thanks a lot for your talk.